You won't believe your eyes when you see a giant cosmic question mark in the sky, and it's linked to one of the most mysterious phenomena in the universe. This is just one of the amazing sights that NASA's James Webb Space Telescope has revealed in deep space. In this episode, we're going to explore this stunning discovery that this telescope has made and what it reveals. Stay tuned. One of the most fascinating targets that James Webb observed was a pair of bright patches of nebulosity called Herbig-Haro objects. These are formed when narrow jets of gas ejected by newborn stars collide with nearby clouds of gas and dust at very high speeds. The resulting shock waves heat up the gas and make it glow in different colors, depending on the chemical elements present. Herbig-Haro objects are very common in star-forming regions, but they are usually hidden by dust and gas from visible light telescopes. James Webb, however, can peer through the dust and see them in unprecedented detail. The image that Webb captured shows two Herbig-Haro objects, named HH46 and HH47, located about 1,500 light-years away in the constellation Vela. The image reveals intricate structures and patterns in the glowing gas, such as knots, filaments, arcs, and loops. The image also shows how the jets from the young stars change direction over time, creating a zigzag pattern in the nebulosity. This is because the young stars are not isolated, but part of a binary or multiple star system. As they orbit each other, their jets are deflected by their mutual gravitational pull. Herbig-Haro objects are very short-lived phenomena, lasting only a few tens of thousands of years. That may sound like a long time to us, but it is a blink of an eye in cosmic terms. By observing them with James Webb, we can learn more about how stars are born and how they interact with their environment. According to NASA, the image of HH46 and HH47 is one of the sharpest ever taken of this type of object. It was obtained using Webb's near-infrared camera, which has a resolution of about 0.07 arcseconds per pixel. This means that each pixel in the image covers an area of about 100 astronomical units at the distance of HH46 and HH47. 1 astronomical unit is the average distance between Earth and the Sun, or about 150 million kilometers. The image also showcases Webb's ability to observe multiple wavelengths of infrared light simultaneously. The image is a composite of 4 different filters: F090W, blue, F115W, cyan, F150W, green, and F200W, red. Each filter reveals different aspects of the gas and dust around the young stars. For example, the blue filter shows mostly hydrogen gas that is excited by ultraviolet radiation from the stars. The red filter shows mostly sulfur gas that is heated by shock waves from the jets. By combining these filters, astronomers can create a detailed map of the physical and chemical properties of the Herbig-Haro objects, such as temperature, density, velocity, and composition. This can help them understand how stars form and evolve in different environments. Another fascinating discovery made by James Webb was a mysterious cosmic question mark that appeared in one of its images. The image shows a galaxy cluster called Abell 3827, located about 1.3 billion light-years away. Galaxy clusters are groups of hundreds or thousands of galaxies that are bound together by gravity. They are some of the largest and most massive structures in the universe. But what caught the attention of astronomers was not the cluster itself, but a small galaxy near its center that looked like a question mark. The galaxy has a bright dot at its core, followed by a curved tail that extends for about 20,000 light-years. The tail seems to be made of stars that have been stripped away from the galaxy by the gravitational forces of the cluster. The question mark galaxy is not only unusual in shape, but also in brightness. It is much brighter than expected for its size and distance. This suggests that it is undergoing a burst of star formation, possibly triggered by its interaction with the cluster. The question mark galaxy is also interesting because it may help us understand one of the biggest mysteries of physics: dark matter. Dark matter is a mysterious substance that makes up most of the mass in the universe, but does not emit or reflect any light. We can only detect it indirectly through its gravitational effects on normal matter. One way to study dark matter is to look at how it bends light from distant sources. This phenomenon is called gravitational lensing, and it can create distorted or magnified images of galaxies behind massive objects like galaxy clusters. By measuring how much light is bent, we can estimate how much dark matter is present in the lensing object. This mysterious galaxy may be an example of gravitational lensing by dark matter. Some astronomers think that the bright dot at its core is actually an image of another galaxy behind the cluster, magnified by a clump of dark matter near the question mark galaxy. The tail may be another image of the same background galaxy, stretched and curved by another clump of dark matter along the line of sight. If this is true, then this galaxy may provide us with a rare opportunity to map the distribution and shape of dark matter in galaxy clusters. This could help us test different theories and models of dark matter and its role in galaxy formation and evolution. The question mark galaxy is not the only example of a galaxy with a strange shape caused by dark matter and gravitational lensing. In fact, there are many other cases where the light from distant galaxies is distorted or magnified by the gravity of massive objects in the foreground, such as galaxy clusters or individual galaxies. One of the most famous examples is the Einstein cross, a quasar that appears as 4 bright spots around a foreground galaxy. The quasar is actually a single object, but its light is split into 4 images by the gravitational lensing effect of the galaxy. The galaxy acts like a giant magnifying glass, bending and amplifying the light from the quasar. Another example is the cosmic horseshoe, a galaxy that appears as a nearly complete ring around another galaxy. The ring is actually an image of a background galaxy that is stretched and curved by the gravitational lensing effect of the foreground galaxy. The foreground galaxy has a very high concentration of dark matter in its center, which creates a strong gravitational field. A more complex example is the bullet cluster, a pair of colliding galaxy clusters that show a clear separation between normal matter and dark matter. The normal matter, mostly gas, is heated up and emits X-rays as it collides and slows down. The dark matter, however, passes through without interacting and keeps moving at high speed. The dark matter can be detected by its gravitational lensing effect on the light from background galaxies. The lensing effect shows that the dark matter is more massive and more extended than the normal matter. These are just some of the examples of how dark matter and gravitational lensing can create strange-shaped galaxies in the sky. By studying these phenomena with telescopes like James Webb, we can learn more about the nature and distribution of dark matter and how it affects the evolution of galaxies and the structure of the universe. We hope you enjoyed this video about some of the amazing discoveries made by the James Webb Space Telescope. If you did, please like, share, and subscribe to our channel for more videos like this one. And don't forget to leave us a comment below with your thoughts or questions about Webb and its observations. Thank you for watching.